Hi there, this is a continuation of John Stewart's calculus textbook titled Early Transcendentals, and this is section 1.1, question 16. The question is asking us to make a rough graph of the number of hours of daylight as a function of the time of the year. So, because it's a function of the time of the year, along the x-axis we're basically putting the different months. So I started at December and went through January all the way to November. And I kind of picked that because the shortest 2 months as far as sun goes, I believe would probably be November and December. So you can see the graph is basically lowest during those two times of the year. And of course, we get the most sun during the summer, so I've kind of peaked it out at May, June, and July. And I kind of guessed that in the middle of summer it's about 14 hours, give or take, which would be, say, it's sunny from 6 a.m. to 8 p.m., for example, which I think sounds about right. And that in winter, I probably underestimate a little bit because my graph suggested there's 5 hours of daylight, which, I don't know, depends on how north you live, that could be true. But it's probably more like there's 8 hours of daylight, like the sun rises at 8 a.m. and goes down to 4 p.m., kind of thing. Anyways, so it did say a rough graph, and this is my rough graph, and you put the hours on the y-axis, and on the x-axis you put the month, and then you try to roughly plot what each month would be. And then maybe you did some dots and then connected the dots with a nice smooth curve, might look better. I was using just my mouse on my PC, and it didn't make the smoothest graph, but the general idea I think is pretty easy to understand. Anyways, thanks for listening, and if you have any questions, feel free to comment. If you like this video, please subscribe, and if there's a specific problem you'd like solved, just feel free to comment down below. Thank you.